Bismillahirrahmanirrahim. Assalamualaikum. So last class we already finished on method of distribution function, right? So we already look in method of distribution function until example number 4. Example number 5 and example number 6. I hope you already do it by yourself. So now method of transformation. Right, so method of transformation is the second method lah that we're going to look. So let's look at the first one. We're going to focus on one continuous random variable and another one is joint continuous random variable. So for the first half of the subtopic, right, which is one continuous random variable. So the purpose is to find a new probability density function for continuous random variable. Right, same objective as previous topic, right, distribution function. So we want to find a new probability density function of a continuous random variable. Now let's look at theorem number 2. So later on kalau you dapat buku tu dah boleh tengok dia punya theorem. So let fx be a value of probability density of continuous random variable x at random number x if the function of y given y equal to mu ux, right, this is a function of fx, is differentiable, right? You can do you can make a differentiation, and monotonic means that either increasing or decreasing, right? Either increasing function or decreasing function for all value within the x variable, and fx is not equal to 0, right? And for this value of x, the equation of y equal to fx means that the new function of fx, right, can be uniquely solved by given to by this formula lah. So f wy multiply with the absolute value of inverse solution of y, right? So inverse solution of y multiply with f wy, and provided that the ux is not equal to 0. So this is the proof of theorem number 2, where x is a increasing function or decreasing function lah, right? So it cannot be either wise lah. So now let's look at example number 8. So now, before we go to example number 8, to find a new probability distribution function in theorem number 2, it says that f wy multiply with absolute of inverse wy, right? Wy means that inverse solution, right? So sekejap lagi kita tengok the definition of inverse solution tu. So this is the function of a new random distribution function, a probability distribution function, right? Now example number 8, given fx is equal to 2x, where x is between 0 and 1, right? So we want to find the probability and the probability distribution function, the probability density function of y equal to 3x minus 1 using a method of transformation. So first step is we need to find inverse solution, which is wy, right? So let me put nicely wy. Oh, still tak nice juga lah. Y. Okay. So inverse function of wy means that y equal to 3x minus 1. So we want to find the value of x. X should be equal to y plus 1 divided by 3. So this is the this is the wy, right? So we want to find inverse solution of wy. So inverse solution of wy should be equal to d, so d dx divided by d dy. So it should be equal to y plus 1 divided by 3. Sepatutnya macam ni, tak ada dx, right? So sepatutnya macam ni. So it should be equal to, with respect to y kan, it should be equal to 1 over 3, right? So we just follow the step kan. Step dia semua sama saja. So very simple. So step number 2, we want to find the function of wy. So wy, so fx is equal to 2x, right? So you just copy balik dia punya function dalam ni, masuk dalam x lah. So 2x, x is equal to y plus 1 divided by 2. So y plus 1 divided by 3. So it should be equal to how much? 2y plus 2 divided by 3, right? Okay, first step is we want to find the inverse solution of wy, and the function of wy is the inverse solution lah, right? And then second step is we find the function of wy. So kita masukkan, gantikan nilai x ni dalam menggunakan y plus 1 divided by 3 lah. So step number 3, right? Step number 3, we use the theorem says that gy should be equal to fwy multiplied with the absolute of inverse wy, right? So this one should be gy should be equal to fwy multiplied with the inverse of wy, right? So this one should be equal to 2y plus 2 divided by 3 multiplied with the inverse of absolute of 1 over 3. So this one should be 2y plus 1 divided by 9. Right? Benda yang sama lah, so keluarkan balik 2 tu. Right? Boleh? Right. So now we know that the function of gy should be equal to 2y plus 1 divided by 9. So what is the domain? Step number 4, find domain of y. So domain of y should be equal to, kita tahu dia punya x, domain for x is 0 and 1. So x is between 0 and 1. So x is equal to y plus 1 divided by 3. So can do the manipulation kan. It should be equal to, y should be 0, 3 plus 1 and minus 1, 2 minus 1, sini negative 1, right? So this one, the range it should be negative 1 y until 2, 0 is elsewhere, right? Okay, very simple, right? Since it's very simple, so I want you to do this one, example number 9. So let me show dulu lah example number 9, nanti I bagi dekat you example number 10 kot, bagi dekat you, senang sikit, right? So now this is a very simple PDF, right? Probability density function. Fx is equal to 1, right? And x is between 1 and 2, right? Between 1 and 2. So find the PDF of y equal to 1 over x using a transformation method. So looking at the new random variable y equal to 1 over x. So when x equal to 1, y should be equal to 1. When x equal to 2, y should be equal to half. X equal to 3, y should be equal to 1 over 3. So this is a decreasing function, kan? So in in this method, we don't care whether it is increasing or decreasing function, right? So first step is we need to find inverse function. So inverse function y equal to 1 over x. So x will be equal to 1 over y. Right, so this is equal to wy. And wy, the differentiate first difference first derivative of wy should be equal to dy 1 over y. So this one should be equal to 1 over, kalau kita bawa dekat atas kan, dia akan jadi macam ni. Exactly, kita boleh nampak lebih mudah kita bawa ke atas kan. So kita boleh nampak y 1 negative 1, right? So this one should be negative 1 multiply y negative 2. Right, so it should be equal to 1 over negative 1 over y squared. Dan lebih jelas, right? Kalau you congak-congak tu mungkin you akan lupa negatif tu. Right? So next is we want to find the function of wy. So since there are no random variable inside fx, right? So it should be equal to 1 jugalah, right? So step number 4 should be equal to gy, sorry, tulis terang-terang sikit. Ni atas sikit, alright. Padam. Okay, gy should be equal to f wy, right? Multiply with the absolute of w first derivative of wy lah. So this one should be, this one kat this color tak cantik Right, 1 multiply with absolute of 1 over negative 1 over y squared. So this one should be 1 over y squared. Right? So our new PDF is 1 over y squared. So now step number 5 is find domain of y. So x is given between 1 and 2. So 1, x, 2. Right? So y should be equal to 1 over, so x is equal to 1 over y. Right? This one 2, 2, 1. So kalau kita bawa dia punya nominator tu ke atas ke tempat lain nak jadikan y sebagai nominator satu saja. So it should be equal to 1 y 2. Sorry, 1 over 1, 1 over 2. Right, it should be equal to like this lah, 1 over 2 y 1 lah. Betul lah? Right? So now we just put it into a official PDF format. So it should be gy equal to 1 over y squared, 1 over 2y until 1. So elsewhere. Right? So this is the new PDF. Okay, boleh eh? So now example number 11. Example number 10 kita tak buat eh? Mana ada example number 10? Oh, okay, okay. Example number 10 ada, don't worry. Tapi I move tempat lain. Sebab dia tak sesuai dekat sekarang. Right? So I move to the next section. So now let's look at example number 11. Can you copy now? Sudah? Right? Are you okay? Basically, I have a lot of example, tapi I tak nak bagi semua lah. You can copy first. Later on dalam workbook ada example semua ni boleh tengok lah. You can do it by yourself. Kita nak habiskan. We try to finish up by today kalau boleh. Right? Oops. Ni. So given fx is equal to 1 over theta exponential negative x over theta. So this is look like exponential PDF, right? So x is more than 0. Okay. So now find the new PDF of y. So this color tak syok. Tukar color ni. Okay. New PDF of y equal to ln x using a transformation techniques. So first step is we need to find the inverse solution or inverse function lah. Sedap sikit dengar kan, inverse function. Right, inverse function of y equal to ln x. So basically should be equal x equal to exponential y, right? So this one going to be w y. Right? So next step is we want to find the first derivative of wy. Right? First derivative of wy should be equal to d dy exponential y. It should be exponential y. Right? Betul? Right? Kita berubah kan? So the next step is step number 3. We want to find the function of wy. So function of wy, 1 over theta exponential negative x is equal to exponential y divided by theta. Alright? We just gantikan the value of x ni dengan x equal to exponential y. So step number 4, right? We want to find the function of gy. So fwy, right? Multiply with the absolute of the first derivative of y, wy. So this one should be equal to 1 over theta. So I tak suka color yang sama dah. Tukar color lain. Hijau. Right? 1 over theta exponential negative exponential y over theta multiply with the absolute of exponential y. So this one you can we can match it kan, dia sama kan. So it should be 1 over theta exponential y minus exponential y over theta. Right, so this is our new PDF. So the domain, sekejap ya. Oh, I lupa record Oh, so okay. Alright, this is the answer kan? Okay. Okay. Any questions so far? If you have no question, then kita masuk example number 12. And cukup lah 12 12, 13, 14, 15, 16. You buat sendirilah. So 12. Example number 12. So example number 12 is quite simple. Right? Okay, cool. Sekejap Example number 12 very simple. 14 simple juga. Alright. 16 also simple. Kita tengok example number 12 dulu, okay? So example number 12, given the PDF of random variable x, so random variable x having a 3 over 2, x negative 2. I think salah dekat sini you need to cancel negative macam dia akan jadi complicated, right? So x power of 2 only, right? So this is the PDF, 3 over 2 x power of 2, where x is between negative 1 and 1. So by using the PDF, find a new PDF for y equal to x plus 2. So first step, so nampak ada beberapa example yang saya bagi ni semua sama saja dia punya method, right? First step, second step, third step, fourth step, right? You just follow the step lah, right? Okay. First step, we need to find the inverse function. So inverse function, right? So y equal to x plus 2. So x equal to y minus 2. So this is a w y, right? So now next is first derivative, right, of w y should be equal to d dy equal to y minus 2 is equal to 1. Step number 3, f wy, it should be equal to 3 over 2 x squared, x equal to y minus 2 squared. Right, nasib baik kita dah cancel negative tadi tu kan, tidak complicated. Right, so this is a new function, not a new function, new f o w y. Step number 4, the new function should be equal to f w y, right, multiply with the absolute value of the first derivative of wy. So tak cantik I tulis y, right? So now we just plug in the value y minus 2 squared multiply with the absolute of 1. So this one still remain the same 3 over 2 y minus 2 squared, right? So the next step is we need to find the domain. 5, domain of y, right, given x is between negative 1 until 1, is it? Yeah. So this one should be y is equal to x equal to y minus 2. This is 1, negative 1. So bawa ke sana. So it should be plus 1 y 3. Is it? So the new PDF gy should be equal to 3 over 2 y minus 2 squared from y is from 1 until 3 lah. 0 is otherwise. Right? Okay? So for example number 13, right? So you can copy this example for now and try to do it by yourself. Or you want me to show the answer? You want to do it by yourself or you want me to show the answer? So do it by yourself, right? So example number 13, number 14. Number 14 is based on example number 13, okay? So it's a same example tapi cuma dia perbezaan dia cari PDF for new random variable lain-lain lah. Right? This is not tilde, this is minus 2y. Right? Ini x equal to 1 minus 2y. So the font yang guna ni nampak macam tilde kan? It's not good. Right? Example number 15. So you do it by yourself lah. Very simple example. Right? You just follow the step. Benda yang sama. Are you copying or you screenshot? Now kita nak tengok theorem number 3. Example number 14. Alright, 14. 14 is based on example number 13. Find x equal to 1 over y. Using a transformation techniques lah. Okay. Example number 15. And 15 sudah. Alright. And example number 16. Okay. Sudah. Alright, now let's look at theorem number 3. Or you want to take... Yes. Okay, good. Right. So I think before we go to theorem number 3, right, kita ambil 5 minit rest, right, for toilet break. Okay, now let's look at theorem number 3. Suppose that x is a continuous random variable with a PDF of fx, right? So let y is equal to ux. This is a inverse solution. Define that different transformation is not one-to-one. It's not one-to-one between the value of x and y. So previous example kita tengok where the value random variable y and x is having a relation one-to-one relation lah. But in this theorem, when we don't have one-to-one relation, right, means that many to one relation. Many to one relation means that you can have two value of x lead to one value of y. So if the interval of over which x is defined can be partitioned into k mutual disjoint, for each of the inverse function. So for example, x1 equal to y1, y1y, w1y, and x2 is equal to w2y until xk equal to wk y. Means that, let's say for example, we have x equal to y squared. So y is equal to square root of x. So this one can take any positive or negative value, right? So if x equal to -1, so y dia akan jadi w1 y. So x equal to 1, w2 y. So dia akan jadi banyak lah. Kalau ni the example for 2 situation lah. So kalau ada banyak lah. So then the PDF of a new random variable y is gy equal to the total of f wi y I multiply with j in the absolute of ji. So ji is the first derivative of wi yi, right? So the formula will look like this lah. F w I y I, right, multiply with the j I. So the j I should be equal to wi, the first derivative of the wi. So since kita ada banyak dekat sini, so means that the first one kita nampak dekat sini. So this is going to be the joint probability, and multiply with it cannot be joint probability. This is going to be fw1 y, right, multiply with the absolute of w1 y1 plus fw2y multiply with w2y2, right? So this is what is the this formula telling us lah, right? So kita boleh tambah semua the value of positive and negative side, right? So kalau kita ada 2, 3, 4 value pun kita boleh tambah sama suka hati lah. Right? Bukan suka hati, ikut the rule lah, okay? Okay. Now let's look at example number 17. Now, example number 17 says that x is having a PDF of x plus 3 divided by 6, where x is between -1 and 1. So we want to find the new PDF of y equal to x squared using transformation techniques, right? Transformation techniques. So the first step, we know that from this random variable, the new random variable, y equal to x squared is not one-to-one relation, kan? So if you try to draw the graph, it should look like this, kan? Dia lebih macam ni, right? So this is y and this is x. Let's say this is the range is from -1 to 1, kan? This is a -1. This is 1, and this is of course equal to 1 lah. This is 0, right? So can be two direction, kan? So either decreasing, this side on the left hand side is a decreasing function, on the left hand side, on the right hand side is increasing function. So now the first step is the inverse solution of y equal to x squared is x equal to square root of y plus minus lah. Okay, so same step juga, benda yang sama. So kejap I turunkan ini ke bawah. Right, second step is let x1 is equal to square root of y. Boleh cantik-cantik ya, bagi you nampak. x1 equal to square root of y. Another one is this is from 0 until 1. Nampak kan? Bila kita, the value of x is positive, so the range is from 0 to 1, right? When x2 is equal to negative square root of y, the range is between -1 and 0. So -1 and 0. This is not 0 lah. Betul kan? So if you look at the the range of x kan? Okay. So now, first step is we know that this is your wy, right? And this is going to be w1 y1. This is going to be w2 y2, right? So look at the formula dekat sini kan, ni formula dia kan. So ji is equal to wiyi, right? So guna color lain. So let's find J1. J1 is equal to W1 Y1. Sorry, W1, first derivative, right? First derivative of W1 Y1 is equal to D dy1. So D dy lah. So kita tak ada joint probability. This is not a joint probability. So D dy equal to 1 over, oops, gambar dia ketegak, right? Square root of y, it should be equal to d dy y1 over 2. So this one should be equal to -1, right? Dia sama juga kan? So it should be ke bawah lah, negative 1 over 2 y negative 1 over 2, right? So this case should be 2 square root of y. Okay? And J2 is equal to W2 Y2. So this is the first derivative of W2 Y2. So this is D dy negative square root of y. Should be equal to D dy negative y1 over 2. So this one should be benda yang sama juga. What is the answer here? 1 over, this is -1, berapa ini? This is not 1 over 2 kan? 1 negative half minus 1. Mana calculator I? Can you calculate here? It's 3 over. Is it? Hey, you tak respond pun. Is negative 3 over 2. Mana I tulis lah? It should be, yes. Oh ya, I confused kan? I confused dengan atas ni, alright? Sorry. So it should be 1 over 2 saja kan? Okay, alright. So jangan confuse, jangan jadi macam I, jangan confuse. Tenang-tenang. Alright, so this one should be negative 1 over 2 square root of y, right? Betul? Jangan tengok atas, tengok sendiri, tengok sini saja. Okay. Right, next step is color ni. So G Y should be equal to, the formula is summation of F W Y multiply with the J I, right? So the first formula, right? So kita tengok the formula is x plus 3 divided by 6. Tu dia kat tepi ni, senang nampak. Plus 3 divided by 6. So x equal to square root of y plus minus, right? So kita ambil the first y plus minus square root of y plus 3 divided by 6. Multiply with the absolute value of j1. So 1 over 2 square root of y. So this is the first one, plus, and then negative square root of y plus 3 divided by 6, multiply with 1 over, this is negative 2 square root of y, right? Cool. So now can you solve this one? So this one should be, let's say kita pemudahkan sikit sebelah sini kan. Square root of y plus 3 divided by 12 square root of y, and this one should be try kat sini dulu. This one should be square negative y, this is positive y negative 3 divided by 12 square root of y. So this one square root of y plus minus 3 divided by 12 square root of y, right? 12 square root of y tu dia sama kan. So this is 12 square root of y, and dekat atas ni oh tak boleh I confuse again, right? Sorry. This is absolute kan, mana boleh ada negatif? Ayo, you all pun tak cakap kan. So this is absolute, mana boleh ada negatif? So still benda yang sama lah. So this is negative square root of y plus 3 divided by 12 square root of y. So dekat sini dia tinggal 3 saja. Right? 3 kah? 3, 6 lah. 3 tambah 3, 6. Right? So square root of y minus square root of y, 0. 3 plus 3 is 6. This one should be 1 over 2 square root of y. Are you okay? So now this is our new PDF. Right, our new PDF. So since let's look at the range kan. Dekat sini kita hanya ada square root of y, right? So for square root of y dekat sini, tengok kita tak ada negative point kan, kita ada square root of y saja, right? Positive value. So since square root of y, so y should be range of 0 and 1 lah, right? 0 and 1 sama saja, mana-mana pun sama. Sebab apa? Dia naik ke atas, right? 0 and y, right? 0 and 1. So our new PDF should be equal to 1 over 2 square root of y from 0 to 1. So this is elsewhere, right? Boleh? Any questions so far? Okay. So let's move to the next example, example number 18. Example number 18, given the PDF of random variable x is 3 over 2x square, right? 3 over 2x square. So by using transformation techniques, find the PDF of y equal to x square. So sama saja, y equal to x square. So now first step is we need to find the inverse solution, right? So let's say let x equal to square root of y plus minus y. So let's say w1 y should be equal to square root of y. w2 y should be equal to negative square root of y, right? So sebab dia ada dua kan, positive and negative side. So second step is we want to find the ji, right? So for j1 it should be equal to w1 y. So the first derivative of w1y should be equal to 1 over 2 square root of y. Benda yang sama kita dah buat tadi, right? So this one should be w2, the inverse, the derivative of w2 y. So this is a negative 1 over 2 square root of y. Step number 4. Okay, step number 4, we need to plug in the value into the formula. So gy equal to the summation of fwi y, right? Sebab kita ada satu y saja, kita tak perlu yi kan. Dekat sini pun sama juga, tak perlukan yi because we only have one y. Okay? So tadi I tak letak kan. So this one should also same, one y saja. Tak perlu ada dua y1 y2 because we only have one y saja. Right? Okay. Now let's look at this one. So multiply with the ji, right? Ni buat macam T pula, J. My J, okay. So this one should be, what is the formula here? Tulis kat bawah ni, senang I nampak, x square. Right? So the first one is 3 over 2 square root of y power of 2. Multiply with the absolute of square root of y, right, plus 3 over 2 negative square root of y squared. Oh, salah. This is 1 over 2 square root of y. Right? So this one multiply with negative 1 over 2 square root of y. Okay? So this one should be 3 over 2 multiply with y multiply with 1 over 2 square root of y plus this is 3 over 2 y multiply with 1 over 2 square root of y. Right? Boleh? So this one should be 3y divided by 4 square root of y plus 3y divided by 4 square root of y. So this one should be 6y divided by 4 square root of y. Okay? So kalau ni kita bawa 6 over 4y multiply with y 1 over 2. Negative. Right? So this one should be 4 divided by 6 divided by 4 is 3 over 2 again. Right? And this one 1 minus 1 over 2 should be square root of y. So this is our new PDF. Okay? This is our new PDF. So still benda yang sama juga kan. So kita tengok dia punya graph it should be from -1 to 1. Benda yang sama. Right? Kan soalan yang sama? Soalan lain. Okay. Right? So, this is from 1 until 1. So, this is -1. This is 1. This is 0. This is 1. Right? This is x, y. So, our domain here is, since square root of y, dekat atas ni lah, mana-mana pun sama, from 0 to 1. Right? So then our PDF gy should be equal to 3/2 square root of y from 0 to 1. Alright. Any questions so far? Buku insyaAllah dapat hari Jumaat nantilah. So hari Jumaat dapat exercise number 1 and exercise number 2. Please copy. Benda yang sama, lebih kurang sama saja. You can do it by yourself. Okay. Example number 1. This is example number 2. Alright. So I think that's all for today. Next class kita akan tengok, we will look into 2 continuous random variable. Right. We try to finish up by this week juga. Right. And next week we will look into moment generating function. Okay. Any questions so far before we end our session? No question, then I think that's all. Thank you very much. Assalamualaikum.